Moshi Moshi students! Today we are going to learn about one-dimensional kinematics. Here are your tips for success. First of all, keep calm and read carefully. By that I mean read the problem carefully. I repeat, please read the problem carefully. I am serious about this. Read the problem carefully. But most of all, and most incredibly important, read the problem carefully. You see what I mean? Alright, first you want to write down your variables in a table. Fill in the variables that are given and that you know. The table is down below. Next, sketch the problem and label your known and your unknown variables. A simple sketch will do, nothing too fancy. Go through each equation one by one and then see which equation leaves you with the variable that you're looking for as the only variable that doesn't have a value. For example, if a equation leaves you with two unknown variables, don't use that equation. Here are the list of kinematics equations. Please take the time right now to pause the video and copy it down. Alright, now the easiest way to pick or choose the right equation is what I like to call the recipe ingredient analogy. If you are given the following ingredients, think about what recipe you could use to feed your hungry stomachs. Sour cream, noodles, spaghetti, tortilla chips, ground beef, onions, olives, brown sugar, garlic, cheese. You know, the yellow kind. Let's take a look. Can we use it for pizza? Well, we don't have tomato sauce or yeast. What about fried chicken? No, we don't even have chicken. Cookies. No, most definitely not cookies, unless you like olive cookies instead of chocolate chip cookies. So the logical answer is nachos! Nachos! Okay, so what you need to do is do the same process. Go through your ingredients or your variables and go through each equation to see which equation you can use. Alright? Now, if you can think back to the analogy, we had a ingredient that we did not even consider. Brown sugar. Okay? In your nacho recipe, you will not need to use brown sugar or even spaghetti. That is the same for these equations. Sometimes a word problem will give you a value that you won't even need to use. Now, in the list below, you can see that these 1, 2, 3, 4, 5 kinematics equations, okay, they all describe motion, okay, how things move, but they can all describe it without a couple of variables. Now, after you do that, you have to ask yourself, after you do your calculations, bring out your calculator, do your math, struggle a bit, does my answer make sense? If the answer is no, for example, if the problem is about a snail that is moving at 1 centimeter every 2 days and is asking for how fast it will go after 2 minutes, and you somehow get 1 million miles per hour, that doesn't make any sense, right? So think about your answer and ask yourself, does it make sense? If not, go back, check your work. Something probably went wrong. Last but not least, you should celebrate. Alright? After you go through all that and you get the final answer and your answer makes sense, you should celebrate. Because every problem finished is another step towards physics enlightenment. And I personally think that this is one of the most important tips. Physics is not the easiest. Kinematics equations will not come to everyone naturally. So every time you finish a problem, give yourself a pat on the back. Alright, I love this quote. Bruce Lee once said, "I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times." Basically what he's saying is practice makes perfect. Okay? And that's true for kinematics equations. The more you practice, the better you get at it. The better you are, the more confident you'll get. The more confident you are, you'll become a physics master. Now, Bruce Lee always reminds me of one of my favorite jokes. What is Bruce Lee's favorite beverage? What the? Now, your list of variables. You'll be using these variables for your equations. V sub 0, okay, that little O is a 0, and you pronounce it V sub 0, is what we call the initial velocity, is what the object starts off with, the velocity the object starts off with. Similarly, the F stands for final velocity. Okay, V sub F means final velocity, A for acceleration, T for time, and delta X. Remember, we learned about delta in our distance and displacement video, but in case you didn't watch it, and you should watch it, delta just simply means change. Okay, final minus initial. So in this case, it'll be final position minus initial position, or final distance minus initial distance. Okay, X of F means final position, X sub 0 initial position, and here we have the glorious table of variables. Now to our left, we have all the variables that you'll need. What you need to do with this table is always start off with this table. Okay, just write it down, make it a habit. After you do that, write down the values that the word problem gives you for each variable. Okay, I wrote down the SI units for each variable as well. It's good to have for your notes. Submarine. When you read a subscript, read the subscript left to right first. Then you will read the variable. For example, V sub F of X, you read it as, okay, you read the Fx first, so final X velocity. Alright, acceleration. Get your pencils ready. Acceleration means it's a change in velocity. Okay, it's the change in velocity by the time it took to change the velocity. Oh wow, that's slightly confusing. Let's try to simplify it a little bit. Basically, it means how fast or how slow the velocity is changing. Okay, it's not actually velocity, but how much it's changing. Okay, if you're speeding up or if you're slowing down. The SI units for velocity or acceleration is meters per second squared. Now, that is the official way to pronounce it, but I want to get in your heads that the definition of meters per second squared is meters per second per second. Now, the reason why I want you to do this is because meters per second means, or is a unit for velocity. So it's velocity over time. Okay, it's a ratio of velocity or speed over a certain period of time. Is how much that velocity is changing. Okay, just like velocity, acceleration is a vector quantity, meaning direction matters. Pluses and minuses will affect your answer. Speed / velocity does not equal acceleration. Alright? Acceleration is the change in speed / velocity. Acceleration due to gravity. Let's try to figure this one out. The official value for acceleration due to gravity that we'll use in my classroom is 9.8 meters per second squared, or 10 meters per second squared, if stated. So if the word problem says use 10 meters per second squared, don't get all confused. Don't think that we're on a different planet. They just round it. It makes the math a little bit easier. Okay. Another note is that acceleration due to gravity always points straight down. So if the problem states that anything moving down is positive, then you use 9.8. Positive 9.8 meters per second squared. But if the problem states that anything going up is positive, then you use negative 9.8 meters per second squared. Okay? Reminder, negative is just the opposite direction of positive. Doesn't mean that it's sad or happy. What does it exactly mean to have an acceleration of 10 meters per second squared? Stroking the chin and think about it. So we know that acceleration means that it's a change in velocity over time. So if we start off at time 0, we have no velocity. Over 1 second, according to 10 meters per second squared, it will increase to 10. Over 2 seconds, your velocity now is 20. It increases by 10. 3 seconds, it increases by 10 again. And so now you're going extremely fast. You're going 30 meters per second. Okay? So notice how the object is speeding up from 10 meters per second to 20 meters per second to 30 meters per second. All right? Think about the accelerator in your car. Pushing it down makes you accelerate. Okay. Now here's a table of couple of objects, and you can compare the 10 meters per second squared to different things, such as what it would feel like for a high jumper, like shooting off with your foot, a emergency stop in a car, or the click beetle righting itself. And if you don't know what that is, just stay tuned.